Okay, well, we're going to try this again. I just did this video and, well, for some reason it only recorded 2 seconds. So I wasted about 12 minutes, 13 minutes of my morning. So let's try this again. So I apologize because it's already written on. Like I said, I already did this video once, but when I finished it, it did not come out. So let's just get right to it because I have a lot to do. And so here we go. We're going to look at properties, rules of exponents. So the first property rule is when you're multiplying like bases, a is the base, you add the exponents. Okay? So over here we multiply the 4 and the 6. And then we look for like bases and we add the exponents. We look for like bases, in this case y, and we add the exponents. And then z does not have a like base, so that just stays the same. In this case, we have an expression or a little group here that's been raised to the n power, so the property here is to apply that exponent to both of these bases. Okay, and so this is a to the first, and this is b to the first. There's an invisible 1 on each one. So you would multiply 1 times n to get n, and 1 times n to get n. So notice how the n is applied to both of them. So in this case, we get 5 to the third power, which is 125. 5 times 5 times 5. And here we have 1 times 3 is 3, and 1 times 3 is 3. Next property, again, similar property. We have a base with an exponent raised to an exponent. So we multiply the exponents together to get our answer. So here we have 2 to the third power, which is 8. 4 times 3, which is 12. 1 times 3, which is 3. And 2 times 3, which is 6. Pretty simple properties. Doesn't take long. But you do need to review them and memorize them so you can recognize them and use them. Okay, next one. Here we're dividing. See the fraction line? Bases are the same. So when the bigger number is on the top, then you would put your answer in the numerator of the fraction. And when the bigger number is on the bottom, then you put the answer in the denominator. And we would subtract the bigger number minus the smaller number. So here we have 3/12. Well, if we divide that, we're going to get a decimal. We don't want that. So we're going to reduce it, which is 1/4. Okay. So the base is c. The bigger number is on top, so we're going to put c in the numerator. 5 minus 2 is 3. The d's will cancel. If the exponents are the same, that's going to cancel. And here the bigger number is on the bottom, so we're going to put e on the bottom. And 6 minus 1 is 5. In this case, we're raising the numerator and the denominator to an exponent. So similar to this property we did right up here, where we distributed the n to each one, we're going to do the same thing here. So 1 times n is n. 1 times n is n. So here we do 4 to the third, which is 64. 4 times 4 times 4. 1 times 3 is 3. And then this base is x. 5 times 3 is 15. Okay. Interesting little property here. If you have a base, any base, whether it's a number or a letter, raised to the 0 power, you're going to get 1. So it's basically just going to cancel out when you're multiplying. So in this case, we have 5 to the first, x squared, y to the 0. Notice it's gone because 1 times 5 is 5. And that made a 1. And then z. Okay, sometimes we want to make an exponent positive. So to do that, if it's in the numerator, you would just make a fraction line and move it to the denominator. And if there's no other term, then you're going to need to put a 1 up here. So let's take a look at this one. So 4 stays in the numerator. We're not going to need the 1 since we have the 4. X to the negative 2, that's going to move to the denominator. Notice the exponent became positive. Y cubed is positive, so it stays. X to the negative 1 is negative, so just this term, z, is going to move to the denominator. Exponent becomes positive. Now if your exponent is negative in the denominator, you're going to want to move it to the numerator. Now notice the negative n is only on the a. That's important. If there's other letters and numbers down here, you have to look at each one individually. So let's take a look at this. So x squared, good. Z to the 5th, good. 5 to the 1st power, good. Y to the 3rd power, good. Z to the negative 4th, bad. We want a net positive exponent, so we just move this term only to the numerator. And that makes a positive 4. And then we can simplify this completely now. Since we have z's like bases multiplying, we add the exponents and we get 9. Everything else just stays. We don't want to have multiple same bases because we should be able to apply a property and combine them down to 1. So notice in our final answer we have an x, a y, and a z. And they're all individual. So, okay, next one. If you have a fraction raised to a negative exponent, if we want to make this positive, we would just flip the fraction. Remember, the math word for flipping a fraction is reciprocal. And when you do the reciprocal of your fraction, the exponent becomes positive. And then you can apply it to the numerator and to the denominator. So that's the first thing we want to do here. So taking this fraction, we're going to find the reciprocal, so we flip it. Numerator becomes the denominator becomes the numerator. And when you do that, the negative exponent becomes positive. Then we apply this to everything. So 3 squared is 9, 4 times 2 is 8, 2 squared is 4, and 1 times 2 is 2. Okay, so make sure you are familiar with these rules of exponents as you work on your worksheets. Thank you.